Now, today we'll be discussing the next topic in the case of your physics, that is the case of your light. So, simple thing. What is the simple meaning of light? What do you mean by light? In very, very simple terms, what do you mean by light? So, anything, a form of energy which is creating, and a form of energy which causes the sensation of vision. A form of energy which is causing the sensation of vision, that particular form of energy that is known as light. Now we all know that we have got the different forms of energy, like the case of your sound. Sound is a form of energy, we say. Light, it's a form of energy. Heat, a form of energy. Electricity, a form of energy. At the same time, heat, a form of energy. Then magnetism, a form of energy. So these are all the different forms of energy. But none of these particular forms of energy is causing us the sensation of vision, right? So this particular form of except the case of your light, the different forms of energy, except the case of your light, none of the forms will cause you the sensation of vision except light, right? So a form of energy which is causing the sensation of vision, that particular form of energy, that is known as light. And these particular light waves, so when you're talking about the case of your light waves, so light also travels in the form of waves, and these particular waves, they keep on propagating in form of, from one place to other place, they just keep on propagating in the form of your electromagnetic waves. So these particular light waves, they are electromagnetic waves which keep on propagating from one place to other place. At the same time, in order that these particular electromagnetic waves keep propagating from one place to other place, they do not require any particular medium. These particular light waves, they can propagate even through vacuum also. Electromagnetic waves, or as a case of your light, they can even propagate through vacuum. The presence of medium is not mandatory. It means if at all the medium is present, or even the medium is not present, in both the cases, even if at all the medium is present or if it is not present, but even in either both the cases, even in both the cases, the light just keeps on propagating from one place to other place. If light is present, sorry, if medium is present, or if medium is not present, in both the cases, the light waves, they keep on propagating from from one place to other place. The presence of medium is not mandatory. The presence of medium is not mandatory. Then the study of light. The study of light is known as optics. The study of light is known as optics. So whenever you are trying to study about any particular form of energy, each and every particular form of energy, that particular thing we assign it a particular name. For example, when you're talking about the case of your sound, the study of sound is known as acoustics. The study of sound is known as acoustics. The study of right, the study of light is known as optics. The study of heat, we call it as calorimetry. So each and every particular form of energy, we assign some name, we give some name. So similarly here, the study of light is known as optics. At the same time, the study about vision of human eye. So when you're talking about the case of your vision of human eye, so we are able to see some objects, right? At the same time, some of the persons, in order to see any particular object, they use a particular device called as your spectacles. They are using spectacles, and in that particular case, some of them, they'll be using the different types of lenses. Some of them might be using convex lens, some of them might be using concave, some of them might be using bifocal lens, or else some of them might be using the case of your cylindrical lenses, the different types of lenses. Why? In order to correct the vision problems, in order to rectify the vision problems, we are using all these particular lenses. So the study about the vision of human eye, that particular study is known as ophthalmology. The study about the vision of human eye, that is known as ophthalmology. At the same time, in order to see any particular object clearly, right? You want to see an object clearly, something that is written in a notebook, something that is written in the textbook, or else anything that is written on the walls, or anything on the bus, or anywhere, right? So in order to see any object clearly, the image of that particular object must fall on the retina for 1 by 16th of a second. So if and only if the image of that particular object is falling on the retina for 1 by 16th of a second, then only a proper vision can be obtained. Then only we can see that particular object very much clearly. If at all the image of that particular object is not falling on the retina for 1 by 16th of a second, then we cannot see that particular object very much clearly. Now, for example, suppose that if at all you are if at all you are traveling in a bus, or if at all you are traveling in a train. Now, when you're trying to look outside, when you're looking outside, right? After traveling in a bus for around 2 hours or 3 hours, so when you wake up, you try to find out till where you have reached. Have you reached Hyderabad or not? Have you reached Vijayawada or not? So there, in that particular case, you are trying to see the name of the place which is written on the shops or somewhere here and there. So sometimes you'll be able to read that but name of the place, sometimes you'll not be able to read. So you're not able to read. You're just able to find you're just able to see the color of that particular name board. Okay, fine. A red colored name board is there. But what is written on that, we cannot identify that. We cannot read that particular thing clearly. The reason, because the image of that particular object is not falling on the retina for 1 by 16th of a second. As long as the image is falling on the retina for 1 by 16th of a second, then we can see that particular object very much clearly. Until and unless the person is not having any defects in his vision. Until and unless that particular person is having any particular defect in his vision. At the same time, the image that is formed on the retina, what is the nature of that particular image? The image formed on the retina is always inverted. This is very, very important, right? This is very, very important. The image that is formed on the retina is always inverted. But suppose that if at all you are seeing at any particular object, you are looking at a wall clock. The moment you are looking at a wall clock, you are able to see that the time is around 7 o'clock in the evening. 7 o'clock in the evening or 7 o'clock in the morning, whatever it is, you're able to see some time. But the image of that one will be falling on the retina, that is inverted. The image formed on the retina is always inverted. But the optic nerves which are present in the eye, they carry the information to the brain, and that particular brain is decoding the information. Optic nerves are carrying the information. So when you're talking about the case of your eye, you have got almost 2 million nerves which are present in the eye. We have got 2 million nerves, right? So 2 million nerves, you're saying. 2 million nerves are present in the human eye which are carrying information to the brain. And these particular nerves, you classify them into, you call them as the rods, at the same time you call them as cones. Rods as well as cones. Now, these particular cones, they are used for identifying the color of the objects. Rods are used for identifying the objects, but wherein cones are used for identifying the colors, the different colors that we are able to see, right? So when you're talking about the case of your nature, so in our nature, we are having only 7 different colors, that is the case of your VIBGR. Only these 7 colors are present in nature. Violet, indigo, blue, green, yellow, orange, and red. These are the 7 different natural colors. So all the colors that we are seeing around us, if at all you look at the case of your color sheet in the case of Asian paints, or as the case of your Nerolac, you find some hundreds of colors in that particular case. You find some hundreds of colors in that. But as per the nature, the original things, right? These are all the ones which we have created. Apart from these particular 7 WebGR, the remaining all colors are the artificial ones, right? So in order to see any particular object, the image must fall on the retina for 1 by 16th of a second. At the same time, the image that is formed on the retina is always inverted in nature. So the rods and cones which are present in the eye, they carry information to the brain. At the same time, when talking about this particular light and the objects that are emitting light, right? So we classify those particular objects into different cases. One is the case of your self-luminous objects. The objects which emit light on their own, depending upon that particular ability, right? So we are classifying the objects into the different categories. One is the case of your self-luminous objects. Self-luminous objects. Now, what are these particular self-luminous objects? The objects which can emit light on their own, which means that they are not dependent upon any other objects. So such objects we call them as self-luminous objects, right? Then, example for the case of your self-luminous objects, you give the case of your sun. Sun is a case wherein it is emitting light on its own. It is because of a process called as nuclear fusion, right? Sun is emitting light. Stars are emitting light on their own because of a particular process called as a nuclear fusion. So if you talk about the case of your sun, Hydrogen gas is abundant, is present in abundant near the sun. And that particular hydrogen gas is continuously undergoing nuclear fusion process, as a result of which helium is generated. Along with that, some million electron volts of energy is also generated. And that particular energy, that is what we are able to see in the form of your light. We are able to experience that in the form of heat, right? So sun as well as stars, they these two, we call them as the case of your self luminous objects. So apart from the case of your sun and stars, we even have got some living beings, right? That is the case of your fire. We call them as fireflies. We call them as fireflies. తెలుగులో వీటిని మినుగురు పురుగులు అంటాం. So they emit light on their own. Fireflies, they are emitting light on their own by a particular phenomena which are calling it as bioluminescence. Bioluminescence. Fireflies emit light on their own by a particular phenomena, by a particular process called as your bioluminescence process. Then when talking about these particular objects, the second category in the case of this one, that is the case of your non-luminous objects. Non-luminous objects. So when talking about the case of your non-luminous objects, so the objects which depend on luminous objects for light, the objects which depend on luminous objects, which means, right, these objects, they are not able to emit light on their own. At the same time, they are completely dependent on self-luminous objects. The best example for the case of your non-luminous objects is that moon is the best example for this one. Moon is the best example. So moon, it just keeps on absorbing light that is coming out from the sun, and then it starts radiating out. So moon absorbs the light from sun and then it emits that one. So moon is not emitting light on its own. Moon is absorbing light from the stars. Sun is also a big star, that is, which is very much close to us, right? So moon is one example for the case of your non-luminous objects. At the same time, you talk about the case of your planets. Even these particular planets, they also absorb light from sun and then they emit light. That is the reason why sometimes we are in a position to see Mars planet, or as the case of your Venus planet, directly, right, without the help of any particular astronomical telescope. We are in a position to see that particular Mars planet, at the same time the case of your Venus planet, directly with the naked eye, right? Because these particular planets, they are absorbing light from sun and then they are emitting. So the case of your moon, the case of your planets, or else the case of your meteors, all these particular things, they absorb light from the sun and then they start emitting it, right? Moon, planets, meteors, comets, or else in simple terms, you take the case of any heavenly bodies, they absorb light from sun and then they start emitting it. So such type of objects, we call them as non-luminous objects. Such type of objects, we call them as non-luminous objects. Then right. Next one. So depending upon the ability of a particular object to allow the flow of light, depending upon the ability of a particular object to allow the flow of light, we classify the objects into three different categories. One is the case of your transparent materials. So depending upon the ability to allow the flow of light, the materials are classified into the first one, the case of your transparent materials. So the materials which can emit light, so which can allow the passage of light, which can allow the flow of light, you call them as transparent materials. For example, suppose that if at all you're talking about the case of a particular glass, you are using your spectacles, right? So that particular spectacle, it could be the case of your convex lens, or it could be the case of a concave lens, or else it could be bifocal lens, anything. So that particular lens is transmitting the light from that side to this side. From both the sides, it's able to transmit the light. It's allowing the light to pass through it. Suppose that, imagine that the lens that we are using, it is not allowing the light. Then in that particular case, will wearing that particular spectacles serve the purpose? We are wearing spectacles because we are not able to see the objects clearly. That is the reason why we are taking the help of that particular convex lens or concave lens. And if at all that particular convex lens or concave lens is not allowing the light to pass through it, then in that particular case, it does not serve any purpose. right? So the materials, or objects which allow the light to pass through them, we call them as transparent materials. So example for the case of a transparent materials, glass is an example for the case of your transparent materials. So glass, even the case of a glass, as of now we give different colors in this one, different varieties in this one. Suppose that if you're taking the case of a particular plain glass, it is a transparent material, 100% transparent material. Suppose that if at all you are taking the case of a particular colored glass, as of now we are taking colored glasses, right? So that particular colored glasses will not allow the flow of light 100%, right? It could be transparent, or else it would be the case of a semi-transparent also. At the same time, the glass that we are using for the case of your offices and the building, big buildings. So even in that particular case, the person who is inside, they can see us clearly. The person who is outside, he cannot see what is happening inside. So it depends upon the time of the day. At the same time, the glasses that we are using for our windows. So during daytime, we cannot see. We can see clearly what is happening outside. Even though the windows are closed, we can see what is happening outside clearly. But the moment the evening time, a person who is standing outside can see clearly what is happening inside. So it depends upon the film that you are using. If at all you're taking the case of a particular plain glass, it's 100% transparent material. At the same time, you take the case of your water. Water is an example for the case of your transparent material. At the same time, air. This is very important. Air is an example for the case of a particular transparent material. Since air is transparent, we are able to see the objects. If at all air is not transparent, we cannot see. Suppose that if at all a vehicle is passing by, and that particular vehicle is emitting huge amount of smoke, right? Or else you are having some sandstorms. So summer season lo general ga will just see దుమ్ము లేస్తా ఉంటుంది. So if at all you're having that particular huge amount of sandstorms, can we see the other side clearly? 100% not, right? So air is an example for the case of your transparent material. Then you talk about the case of your opaque materials, right? So the materials which do not allow the flow of light, which do not allow the flow of light, we call them as opaque materials. An example for the case of your opaque materials. So you give number of examples. All the metals, right? So all the metals, they are the examples for the case of your opaque materials. At the same time, wood is an example for the case of your opaque material. Metals, wood, thermocol, right? At the same time, the walls, right? All these particular materials we call them as opaque materials. Then you talk about the case of your the third category, that is what you call them as semi-transparent materials, or else a better word, instead of using the word semi-transparent, we use a technically correct word, the more better word, you call them as translucent materials. And translucent materials. So what are these particular translucent materials? So these particular translucent materials, they allow 50% of light to pass through, and they block 50%. 50% of light is allowed, and then 50% of light is blocked. So such type of materials we call them as translucent materials. Such type of materials we call them as translucent materials. So when you're talking about the case of your translucent materials, so what are the examples for the case of a translucent materials? The best example for the case of a translucent materials: butter paper, oil paper. The maybe the case of your butter paper, maybe the case of your oil paper, or else any particular glass which is rough, right? Rough glass is an example for translucent materials. We call all these particular materials as translucent, right? We call them as translucent materials, which can allow the light partially. They cannot emit the light 100%, they emit the light only partially. So such type of materials we call them as translucent materials, right? Then now we are saying that light is traveling from one place to other place in the form of electromagnetic waves. But regarding the propagation of light, how light is propagating from one place to other place, for this particular thing we have got number of theories, right? So the first one in that particular theory is the case of your Newton's theory, or else you can even call this particular theory as Newton's corpuscular theory. Newton's corpuscular theory. So the first theory regarding the case of your light, how light is propagating from one place to other place, this is the first theory that was put forward, right? Newton's theory, or as in case of your Newton's corpuscular theory. So according to Newton, light always travels in the form of small packets, in the form of corpuscles, right? Small particles or a small packets, which you call them as corpuscles. Light always travels in the form of corpuscles. Now, he's saying that according to him, light is not traveling in the form of waves, but is traveling in the form of small packets, which are calling it as small particles, or small packets, which are calling it as corpuscles. At the same time, according to the case of your Newton, according to Newton, the speed of light in denser medium, the speed of light in denser medium is greater when compared to the speed of light in the case of your rarer medium, which is an absolute false, right? Basically, we know that the speed of light in rarer medium is high when compared to the case of a denser medium. But as per the case of your Newton's theory, the speed of light in denser medium is high when compared to the case of your rarer medium. At the same time, the different colors that we are able to observe, the different colors that we are able to see, is because of the difference in the different sizes, right? You can even say the different colors that we are able to see is because of the different sizes of corpuscles. Now these particular corpuscles which are carrying the light energy from one place to the place, they're having different sizes, and it is because of these particular different size of these particular corpuscles, we are having the different colors around us. Even this one is also wrong, right? So this particular theory which was put forward in the very first case, right, this could not be accepted. This particular theory is completely discarded, right? So this particular theory is completely discarded. So we need to go for the case of a next theory. So according to the case of a next theory, right, so the next theory was proposed by, so regarding the propagation of light, the next theory was proposed by Huygens. The next theory was proposed by Huygens. This particular theory that was proposed by Huygens, it is also known as Huygens wave theory. So this theory that was proposed by Huygens, it's also known as Huygens wave theory. So according to this particular theory, right, he has corrected one particular statement that was given by Newton. What was that? The speed of light in rarer medium is greater when compared to the case of a denser medium. This particular thing was rectified. This particular thing was corrected. But wherein he said that light is traveling from one point to other point, light is traveling from one place to other place in the form of mechanical waves. Now we all know that light waves are not mechanical waves, light waves are electromagnetic waves, right? So according to Huygens, light is traveling in the form of your mechanical waves. At the same time, light for the propagation of light, there is a particular medium called as ether. But he could not explain what is this particular ether made of. He could not explain what is ether consisting of. Right? So according to the case of your Huygens, light always propagates from one place to other place, right? In a particular medium which you are calling it as ether, in the form of your mechanical waves, in a particular medium which are calling it as ether. But he could not explain what is this particular ether made of, what is this particular ether consisting of. At the same time, he corrected one particular thing that was proposed by the case of your Newton, that the speed of light in the case of your rarer medium is high when compared to the case of your denser medium. That particular thing was corrected. But he could not explain ether. At the same time, he said that light waves are propagating in the form of your mechanical waves, which is an absolute false. Right? Then, the next theory. So the next theory that comes here is the case of your Maxwell's electromagnetic theory. Maxwell's electromagnetic theory. Now, according to the case of your Maxwell, So light is traveling from one place to other place in the form of electromagnetic waves. Light travels from one place to other place in the form of electromagnetic waves. Wherein, in the case of your electromagnetic waves, the electric field as well as magnetic field both are perpendicular to one. So light waves are traveling from one place to other place in the form of electromagnetic waves. That's true. At the same time, what is this particular electromagnetic wave? What are these particular electromagnetic waves? So these particular electromagnetic waves, in the case of the electromagnetic waves, the electric field as well as the magnetic field both are always present, both are always found perpendicular to one another. Both are always found perpendicular to one another. Then the final theory that comes into picture is the case of your Planck's theory, right? So this particular theory is also known as Planck's quantum theory. This particular theory is also known as Planck's quantum theory. This was proposed by Max Planck. Now, based on this particular Planck's theory, or as the case of a Planck's quantum theory, even the Niels Bohr's model in the case of atomic structure, in the case of your atomic structure, right? So we discussed about the case of your Bohr's model, Rutherford model. So Rutherford model has got some defects. So that particular defects were overcome, that particular defects were rectified by the case of a Niels Bohr's model. And that particular model is based on quantum theory. This is based on quantum theory. So Max Planck has proposed this particular theory, which are calling it as quantum theory. So as per the case of your quantum theory, so the light, it just travels from one place to other place in the form of small energy packets. Light always travels from one place to other place in the form of small energy packets, right? And these particular energy packets, you call them as photons, or else you even call them as quanta. So light always travels from one place to other place in the form of photons, or else in the form of small energy packets, which are calling it as quanta. So what is this particular quanta? Right? The energy of a particular photon, or as the energy of a particular quanta, is given by E equal to h nu. The energy of a photon, or as the case of your energy of a quanta, that is given by E equal to h nu, where this particular nu is known as nu is frequency of that particular radiation. At the same time, nu is h is Planck's constant, where h is Planck's constant. At the same time, nu is frequency. H is Planck's constant and nu is frequency. So the energy of a particular photon, or as the energy of a particular quanta, is given by this particular relation E equal to h nu, where h is Planck's constant and nu is frequency, and the value of this particular Planck's constant is given by 6.6 into 10 power minus 34 joules second. It is numerically a constant value. So these are the four different theories that were put forward regarding the propagation of a particular light wave. Right. The first one was the case of a Newton's theory, Newton's corpuscular theory. The second one was the case of a Maxwell's wave theory. That is sorry, yes, Huygens wave theory. At the same time, the third one, the case of your Maxwell's electromagnetic theory, and finally the case of your Planck's quantum theory. The four theories that were put forward. Right. Then we move on to the case of your next thing, that is the case of your intensity of light. Intensity of light. Now, what are the units for the case of your intensity of light? So when we were discussing the very first topic, that is the case of your units, we were talking about the case of your fundamental quantities. Now, the fundamental quantity, as for the case of your SI system, we are having 7 fundamental quantities. So what are they? Length, mass, time, electric current, at the same time temperature, then the intensity of light, at the same time the quantity of a particular substance. So intensity of light, we're talking about the case of your intensity of light, and this particular intensity of light, basically it is a fundamental quantity, and the unit for this one is candela. Unit for this one is candela. So when talking about the case of your intensity of light, the intensity of light, it is dependent upon distance. The intensity of light depends on distance. So in what way? So we say that the intensity of light is inversely proportional to the square of its distance. The intensity of light is inversely proportional to the square of its distance. So it means that, suppose that if at all the distance is increasing, The distance from the source of light is increasing. The distance from the source of light is increasing. Then in that particular case, the intensity of light, obviously it has to decrease. For example, suppose that if at all you are taking a room like this, a living room. So when you're talking about the case of a particular living room, imagine that here at this particular place, you're having a tube light. Tube light is fixed on a wall. It is at height of around 8 feet. Suppose that if one kid or one student is sitting at this particular point, right, he's sitting here and is studying something. So the person who is sitting very much close to the tube light will be having a very good brightness or brightness on his book. He'll be able to read comfortably without any problem. But the moment you have got one more person sitting at this particular corner, you have got only one light. You have got only one light, right? One kid is sitting here, other kid is sitting here. Then in that particular case, this person, the amount of light that is received by this particular person will be very less when compared to this particular case. Simple reason. The light that is coming out from the source of from this particular source is not increasing, is not decreasing. What is changing? The distance is changing. This kid is sitting very much close, but wherein he is sitting very much far, which means as the distance is increasing, the intensity of light, it just keeps on decreasing. And that particular intensity of light is inversely proportional to square of its distance, At the same time, if you just remember, even the intensity of sound is inversely proportional to, right, square of its distance. Intensity of sound is directly proportional to square of its amplitude, but it's inversely proportional to square of its distance. As you just keep on moving away from the source of sound, the intensity of sound, it keeps on decreasing. The same thing is applied even here also. So whether you are going away from the source of light or source of sound, the intensity of light, the intensity of sound, it just keep on decreasing, right? So the intensity of light, unit for this one, it is known as candela. But what is the meaning of the word intensity of light? What is the meaning of the word intensity of light? So here when talking about the case of your intensity of light, the amount of light that is received per unit area of cross section, right, that is known as the intensity of light. The amount of light that is received per unit area of cross section. Now for example, suppose that here I'm taking a square box like this. This is 2 feet by 2 feet, right? Something like this. At the same time, here you are having one more a small area. Onto this particular big area, you are focusing a torchlight. The moment you are focusing a torchlight onto this one, that particular torchlight will cover a complete area of this one. It is covering the complete area. At the same time, you are taking one more laser gun. Laser gun. I'm talking about the case of a laser. I'm not talking about a torchlight. The first case, you are focusing with the torchlight. Second case, you are focusing with a laser. The moment you are using a laser, you will be able to focus at a very small region, something like this, right? So here in this particular case, photons, we need to count the number of photons which are falling in this particular area. At the same time, the number of photons which are falling in the same area with respect to this one. Because when you are comparing two things, the areas of both the things must be the same, right? So here suppose that if the area of this one is something around 1 centimeter square, laser gun is able to focus on an area of 1 centimeter square. So even in this particular case, we need to consider a small area which is of 1 centimeter square. In both these particular areas, we need to count the number of photons. If you count the number of photons, you find that here in this particular case, the number of photons are very high when compared to this particular case. What is the reason? Because the light that is coming out from the case of your laser gun, or as the photons that are coming out from the case of your laser gun, all the photons are focused in this particular area. But the photons that are coming out from the case of your torchlight, they are spreading into this particular wide area like this. As a result, you find some particles here, some photons here, some photons here. Each and every particular way you'll be finding some photons. But the photons that are coming out from the case of your laser gun, they are concentrated only at this particular point. That is the reason why the intensity is maximum here, right? So the intensity of light means the number of photons, the number of particles which are focused in unit area of cross section. Unit area in the sense 1 centimeter square, 1 millimeter square. That is known as unit area, right? The unit for this one will remain the same as candela. Then you go for the case of your next term, that is the case of your luminous flux. Luminous flux or else luminous flux density, both mean the same. So when talking about the case of a luminous flux, the units for this one, the reason for discussing about this one is we need to talk about the case of your units. Intensity of light, that is the case of a candela, but wherein luminous flux, the units for this one is lumen. What do you mean the term, right? What do you mean by this term, luminous flux? So when talking about the case of your luminous flux, the amount of light that is coming out from a source through 1 degree angle, suppose that for example you are focusing a torchlight like this, or else I'm having a light focusing in the downward direction. The light that is coming out from this particular source will be spreading out in this complete area. At the same time, part of the light will be focused even the top side direction also, which means that the light that is coming out from any source will try to cover an angle of 360 degrees, an angle of 360 degrees. So the amount of light that is coming out from any source through an angle of just 1 degree, any particular 1 degree. So if at all you are considering between 255 and 256 degrees. So the light that is coming out through this particular angle, or else 90 and 91, or else 130 and 132, 131. So any two angles, right? Any two consecutive angles. That could be the case of your 255, 256, or else it could be the case of 301 or 302, whatever it is. The amount of light that is coming out from any source through 1 degree angle, that is known as luminous flux, right? Then we move on to the case of your next term, that is the case of light year. That is light year. What is light year? What is light year? The distance that is traveled by light, the total distance that is traveled by light in one particular year or one calendar year, that is known as light year. Now, for example, suppose that when I'm talking about the case of 1 year means 365 days. 1 year means 365 days, right? And each and every day we have got 24 hours. Each and every day we have got 24 hours. So 1 hour, it means 60 minutes. 1 hour means 60 minutes. And in 1 minute, we have got 60 seconds. 1 minute, we have got 60 seconds. Then in 1 second, the speed of light for every particular second is 3 into 10 power 8 meters per second. 3 into 10 power 8 meters per second. So the speed of light, right, is 3 into 10 power 8 meters per second. So if at all you multiply all these particular things, we will get the total distance that is traveled by light in one particular year or one calendar year. So that is something around 9.46 into 10 power 15 meters. 9.46 into 10 power 15 meters. 1 light year equals to 9.46 into 10 power 15 meters, or else you can even write 1 light year equals to 9.46 into 10 power 12 kilometers. 9.46 10 power 15 meters, or else 10 power 12 kilometers. But we need to remember this particular value. Why? Because this is in SI units. Kilometers is not an SI unit, meter is an SI unit, right? So 9.46 into 10 power 15 meters, this is the value of one particular light year. So the distance traveled by light in 1 year, that is known as light year. And this particular light year, it is a unit for distance. Light year is the unit for distance. This is a very, very regularly asked question. Light year is the unit for distance, right? It is used for measuring the distance between any two heavenly bodies. Suppose that if you're talking about the distance between two planets, or else suppose that if you're talking about the distance between uh, two meteors, or else the case of your two comets, right? So there in that particular case, we are talking about one particular unit which you are calling it as light year. Two, in simple terms, two astronomical objects. Two astronomical objects. In order to measure the distance between two astronomical objects, we are using this particular term. We are using this particular unit which you are calling it as light year. At the same time, in order to measure the distance between, sun and earth, suppose that if at all you're talking about the case of distance between sun and earth, so for this particular thing, only for the case of a sun and earth, we have got a special unit that is known as astronomical unit. Astronomical unit. So this is used for measuring the distance between sun and earth. Apart from the case of your sun and earth, we use light year for all the astronomical objects. right? Astronomical unit is used for measuring the distance between sun and earth, and at the same time one astronomical unit equals to 1.496 into 10 power 11 meters. This is the value of 1 AU, or its astronomical unit. So astronomical unit is used for measuring the distance between sun and earth. At the same time, the biggest unit for measuring the distance, is the case of your parsecond. Parsecond is the biggest unit for measuring the distance. So when you're trying to measure the smallest distance, for me, 10 power minus 15 meters, that is the smallest unit for measuring the distance between any two things. 10 power minus 15 meters, right? One Fermi. At the same time, so for measuring the biggest, right, the biggest unit for measuring the distance between any two objects, that is the case of your parsecond, and 1 parsecond equals to 3.26 light years. 1 parsecond equals to 3.26 light years. So this is something about related to the case of your introduction regarding the case of your light. So when you speak about, when you talk about the case of your light, how it just keeps on propagating from one place to other place. So there in that particular case, we need to talk about the most important thing, that is the case of properties of light. So light has got, or else light exhibits 10 different properties. Rectilinear propagation of light, speed of light, reflection, refraction, total internal reflection, dispersion, scattering, interference, diffraction, as well as polarization. So these are the 10 different properties we need to learn, we need to know. At the same time, the applications of each and every particular property of light. Apart from properties of light, we need to focus on mirrors. We need to focus on the case of your lenses, the different types of mirrors, spherical mirrors, right? In case of your spherical mirrors, you have got convex mirror, concave mirror. At the same time, other type of mirrors, that is the case of plane mirrors. And lenses, convex lens, concave lens. Apart from this, electromagnetic spectrum, right? So, when talking about the case of your light, what is light? It's a form of electromagnetic radiation and a non-mechanical wave. Light is an electromagnetic radiation, at the same time it's a non-mechanical wave, and these particular non-mechanical waves do not require any particular medium, right? Non-mechanical waves, they do not require any medium for propagation. They are what? They are the case of your electromagnetic waves. Then when the reflected light from any object reaches the retina for about 1 by 16th of a second. So in order to have the proper vision, the image of that particular object must fall on the retina for 1 by 16th of a second. Then only will be able to have a clear vision regarding that particular thing. Right? Then the study of light is known as optics. Then the study about the vision of human eye, that is known as ophthalmology. The study about vision of human eye, that is known as ophthalmology. At the same time, the measurement of light, the measurement of light. So this particular study is known as photometry. So how to measure the light? At the same time, a device which is used to measure the intensity of light, that is what you call it as a photometer. The study is known as photometry and the instrument is known as photometer. Then, self-luminous objects. The objects that emit light by themselves, the objects that are emitting light by themselves, we call them as self-luminous objects. Example, sun, stars, at the same time, fireflies. At the same time, fireflies. Now, this particular thing, electric bulb, at the same time, the case of a glowing candle, we do not consider them as the case of a self-luminous objects, but these two we consider them as artificial luminous objects. The case of your electric bulb, at the same time the case of your glowing bulb, glowing candle, we consider them as a case of your artificial luminous objects. We do not consider them as self-luminous objects. Then coming to the case of your non-luminous bodies, the bodies that always depend on, so any particular body that is completely depend upon the case of your self-luminous objects, we call them as non-luminous. Example, the case of your satellites, the case of your planets, at the same time any particular wooden piece. All these particular things, they are dependent upon the case of your luminous objects. Then transparent materials, The materials that allow the flow of light to pass through them. So any particular material that is allowing the light to pass through them, example like glass, water, air, all these particular things we call them as transparent materials. Then you talk about the case of a translucent materials. So what are translucent materials? Semi-transparent materials, right? Semi-transparent materials. So the materials which are allowing 50%, which block 50%, right? They are allowing only a part of the incident light. Such materials we call them as translucent materials, right? Example: rough glass, butter paper, oil paper, and so on. Opaque materials, the materials that do not allow the light to pass through them, the materials that do not allow the light to pass through them, they never allow the light to pass through them. Example, maybe the case of your planets or is the case of your satellites. Human body is the best example. Metals are the best example. Wood is the best example for the case of your opaque materials. Even suppose that if at all you're talking about the case of a mirror, is it a transparent material or opaque material? Mirror is an example for the case of a particular opaque material. Mirror will never allow the light. Mirror will just reflect the light that falls on it. That is the reason why mirror is always an opaque material. Then come to the case of your intensity of light. The number of light rays that are incident per unit surface area, per unit area. That is known as intensity of light. And unit for this one, candela. The intensity of light is inversely proportional to, it's always inversely proportional to square of the distance. I is proportional to 1 by d square. I is proportional to 1 by d square. Then what is light year? The distance traveled by light in 1 year, that is known as light year. So what is the value of light year? So 1 light year equal to 365 days. Each day 24 hours. Each and every hour 60 minutes. 1 minute 60 seconds. And in 1 second the speed of light 3 into 10 power 8 meters. So finally we get 9.46 into 10 power 15 meters, or else 9.46 into 10 power 12 kilometers. Then part second, the unit that is used to measure the separation between, or else the distance between any two stars, right, to heavenly object. That is what you call it as part second. So 1 part second equal to 3.26 light years. And this particular part second, it is the biggest unit to measure the distance. Remember this one. Part second is the biggest unit for measuring the distance. Wherein for the smallest unit for measuring the distance is Fermi, right? And the value of Fermi is 10 power minus 15 meters. 10 power minus 15 meters. Here comes it. The smallest unit to measure the distance is Fermi, and the value of Fermi is 10 power minus 15 meters. Then you talk about the case of an astronomical unit. It is used to measure the distance between Sun and Earth, right? And the value of 1 AU, 1.496 into 10 power 11 meters. A small correction here. So this is 1.496 into 10 power 11 meters. That is the value of 1 AU. Then you talk about the case of your theories regarding the propagation of light. So according to the case of your Newton's corpuscular theory, light is emitted by a luminous body which always travels in the form of minute particles, and those particular minute particles we call them as corpuscles. Very, very small particles which are calling them as corpuscles, right? And these particular corpuscles, they travel with more velocity in denser medium and with less velocity in rarer medium. Indicates that the speed of light in denser medium is high when compared to the case of rarer medium, which is absolutely wrong. Then the color of the light, it depends upon the size of the particles. Whatever is the size of these particular corpuscles, so based on the size of the corpuscles, the color, it just keeps on depending on that, right? Then coming to the case of your Huygens wave theory. Huygens wave theory. According to this theory, light propagates in the form of mechanical waves, right? According to Huygens, he's the only person who suggested that light waves are mechanical waves. And at the same time, that particular mechanical waves require a medium which are calling it as ether. But he could not say, he could not explain what is ether, where it is present, what is the composition of that one, that could not be explained by Huygens. Then this theory states that the velocity of light in rarer medium is more when compared to the case of your denser medium. Whenever you're comparing the rarer medium and denser mediums, the speed of light in rarer medium is high when compared to the case of your denser medium. So the defect, the flaw in the case of your Newton's theory has been overcome by the case of your Huygens theory. Then, according to him, no material medium is required for the propagation of light. This is a true one, right? Light waves can propagate even through vacuum also. They do not require any particular medium. This particular thing was proposed by the case of your Huygens wave theory. Then the next one, that is the case of your right, electromagnetic wave theory, which was proposed by Maxwell. So according to the theory, light waves consist of electric as well as magnetic components. Light always it consists of electric component as well as magnetic component, and these two components they are always perpendicular to one. They are always perpendicular to one another. At the same time, light can travel through all the transparent materials at the same time vacuum also. It means that light is able to travel through air, at the same time it's able to travel through water, through glass, at the same time even in the case of your vacuum also. The speed of light, the speed of light either through air or vacuum, it is given by 3 into 10 power 8 meters per second. 3 into 10 power 8 meters per second. Then the last theory here in this case, that is the case of your quantum theory. So according to the case of your quantum theory, light is propagating in the form of small energy packets, and those particular small energy packets we call them as photons, or else you even call them as quanta. You call them as photons, or else you call them as quanta. At the same time, the energy of each and every particular photon is given by E equal to h nu, where h is Planck's constant and nu is known as frequency. Right. So this is something about the case of your regarding the case of your Newton's theories, or as the case of your Maxwell theory, quantum theory, and so on. Right. So the next class we'll be talking about the case of your properties of light, at the same time mirrors, as well as the case of your lenses. It's a very big topic, right? Thank you.